Okay, so this is our final video on simplifying radicals. In the first video, we just talked about the basic idea of using the distributive property to help us do these sorts of problems such that we do not have approximate answers. In other words, there's no decimals when we're done. We haven't rounded anything off. So that's the whole idea of finding a simplified exact value. In the second video, we looked specifically at how to do this with square roots. And here we are in our final video. We're going to look at other types of radicals in this video. So our learning objective hasn't changed. In all three videos, we're trying to simplify radicals by finding a simplified exact value. Now, I've got copied here the procedure that we wrote down in the last video. This is what we said we we're going to do with square roots, but I've changed one word. This one right here. In the last video, I said find perfect squares. Now I'm saying find perfect power. And what I mean by that, you'll see as we get into the examples in this video. But the difference is now, since we're not working with square roots, we're working with other roots instead. Since we're going to work with other roots, we need to find powers that match the root that we're working with. All right, so you'll see what that looks like in just a second as we start our first example. So let's say, for the sake of argument, that we have been asked to simplify the cubed root, so not the square root anymore, but the cubed root of, let's do the cubed root of 16. How about that? The cubed root of 16. Okay, so we want to start the same. It's the same 5 steps. The only difference is what we're going to look for in step 2. So I want to start the same. I want to factor the number 16. So 1 times 16, 2 times 8, and 4 times 4. Okay, that's as far as I can go. All right. Now, we said we want to look for a perfect power. Now, this is where it gets a little bit tricky. I have posted on Canvas, and we made this little table in our notes a while ago, a table that has some perfect powers. Okay, and so since we made this in our notes a while ago, you might be comfortable with this. But the idea is if I take the numbers in this left-hand column and I square them, I'm going to get this numbers in this column. If I take this number and I cube it, I'm going to get the number in this third column here. And if I take this number and I raise it to the 4th power, I'm going to get these numbers in that final column there. And you can see I've left some of these blank, and that's intentional. You don't necessarily need to know every power for every number. These are some numbers that might be helpful. I also talked about in the last video that you can make this table yourself on your calculator by just going to the y equals menu and typing in x squared if you need squareds, type in x cubed if you need cubes, and type in x to the 4th power if you need these, and then go to the table view in your calculator and you can find all these. Okay, now let's actually get back to the problem at hand. We're trying to find the cube root of 16. We're on step 2. We're trying to find a perfect power, specifically a 3rd power. And here are our list of factors. So from this table, what I want to do is go down my cubed power list. And I want to find the biggest one of these numbers that's in that list. And so what I would do is I would start with my biggest number, 16. Is that in my cubed table? Now, it's in my square one, right? But I don't care about squares right now. I need cubes. Is 16 in my list of cubes? And the answer is no, it's not. So then I go to my next number, 8. Is 8 in my list of cubes? Yes, 8 is right here in my list of cubes. 8 is equal to 2 cubed. That's what 8 is equal to. So for step 2, find a perfect power, the biggest one. This is the one that I'm going to use. And now everything else from this point on is the same as the last video. I'm going to take 16. And I'm going to rewrite it as my perfect cubed times the other factor. So in this case, 8 times 2. Once I do that, I can distribute my radical. And then after I've distributed my radical, I will take the cubed root of the one that works out even. So that's what I mean by as able. The one that works out nicely, the one that does not give me a decimal. That one I'm going to do. So from my table, I saw that the cubed root of 8 was equal to 2. Although, again, you can always type that into your calculator or just go from memory, whatever. This one is not in my table, so it's not going to work out nicely. So I just leave it as a radical, and that becomes my answer. Okay, so that's the only thing that's different when I'm working with a higher power, is when I get to this step right here, I'm not necessarily looking for squares every time. I might be looking for cubes or fourth powers or whatever. So let's do one more example, and then we will be done with this lesson. Example number 2. Let's find the fourth root of, I need to find a number that works out nicely here. Let's say I'm going to do the fourth root of 162. 162. Now that's a pretty big number. And immediately you might run into the issue of, I'm not sure I can factor 162. Now, don't forget you've got a calculator, so you can use your calculator to help you. But with that said, pause the video right now, give this a try. All right, so hopefully you've at least tried it. What I'm going to do is I'm going to just do the factoring part. So if you struggled with the factoring part, do that. And then maybe after you're done, or after I finish the factoring part, then maybe I can go from there. So I know that 1 divides everything. 1 times 162. 162 is even, so I know it's divisible by 2. So it's 2 times 81. Is it divisible by 3? Yes, it is. 3 times 54. Is it divisible by 4? Nope. Is it divisible? I know it's not divisible by 5 because it doesn't end in a 5 or a 0. Is it divisible by 6? Yes, it is. You know what? If 4 didn't divide it, 8 can't divide it either because 8's divisible by 4. But, you know, if you tried it, oh, I forgot 7. I don't think it's going to be divisible by 7. Ah, I'm pushing all the wrong buttons. There we go. Nope, not divisible by 7. I know it's not divisible by 8. I can try 9. 9 worked. It's not going to be divisible by 10 because it doesn't end in a 0. And it's not going to be divisible by 11 because it doesn't follow the right pattern for 11. But if you're not familiar with that pattern, you can always try it and make sure. It's not going to be divisible by 12 because of the fact it's not divisible by 4. I think it is not divisible by 13. No, it's not. 14, it's not. 15, it's not. It can't be 16 because it's not divisible by 4. 17, it's not. And now I'm to 18, so I'm starting to go back up the other side, so I'm done. There's all the factors. So that is a little bit lengthy. But if you run into a number that you don't know how to factor, that's what you do, is you just start dividing it on your calculator to see what works. Okay? So there we go. We've got our list of factors. The next thing I want to do then is find the biggest one that's a perfect fourth power. A perfect fourth power. So if you know the fourth powers off the top of your head, great. If not, grab this list from the Canvas site or from your notes. Go down the column of perfect fourth powers and see what's in there. So the first one is 162. That's not in there. Then I have 81. 81 is in there. So that's what I'm going to use, is 81 times 2. So I'm going to split this 162 into an 81 times 2 inside of my radical. Then I can distribute my radical. Now, the fourth root of 81, according to my table, is equal to 2. But again, if I'm ever not sure, I can always type that into my calculator. And this part, because 2 is not in my table, right? 2 is not a perfect fourth power. So this is not going to simplify, so I'm done. This is my answer, 2 times the fourth root of 2. Okay, so there are a couple of examples. Again, if the size of these numbers is intimidating to you, don't forget you can use your calculator, but also rest assured of the fact that the bigger type of problem that you're going to see much more often are square roots. So as long as you're comfortable with square roots, you're going to be okay in our class. These types of problems will only come up rarely and on occasion. So it's nice if you can do them. But if you can't, you'll still pass our class. It'll be all right. So with that said, make sure you go on and do the homework for this assignment. Thanks for watching.